All right, welcome to this video. This is going to be on biomes. For biomes, this table down here at the bottom is going to be pretty important to kind of differentiate between them. And so a biome refers to two factors of a geographic area. It refers to how much rainfall there is and to the temperature of it. And so this table shows you the 9 different main types of biomes. There are sub-biomes that kind of bridge the gap between them, but these 9 are the important ones. And so we can look at the tropical column, and so if there is an area where the temperature is consistently high, based on the rainfall, it would either be one of these 3 things. And so this table is probably important to put down. I'm going to talk about 3 different types of these: deserts, grasslands, and forests, and we'll kind of show you what biomes look like. And so this is a climate graph, and you're going to see several of these. The climate graph is really valuable because it shows us both the temperature and the precipitation in a biome, and so you can determine what biome you're dealing with based on the climate graph. And then from the biome, you can kind of determine what kind of species are going to live there, what kind of plants would grow there, that type of thing. And so the way you read one of these, this one's color coordinated, which makes it easy. And so these bars on the graph here correspond to the precipitation. So if we look at the month of January, we can see that there's 150 millimeters of precipitation. And so right off the bat, we're probably eliminating the dry biomes here. It's probably not a desert if we're getting that much rainfall. The other important piece to it then is the temperature. And so the curve is going to be the temperature line. And so we can see that we have very clear seasons, right? We are very cold in the wintertime, January, February, and we are very warm in the summertime. And so that differentiation of seasons typically refers to temperate. And so we would fall, for this case, as the deciduous forest, right? This is relatively high rainfall, and so you'll be able to compare and kind of tell the difference. First, what we're going to talk about are deserts. Deserts are going to be characterized by having very little rainfall, and so this is a climate graph for deserts, and you can see the bars for the rainfall are all down here on the bottom, right? Less than 50 millimeters every month. Some important things to know about deserts are because the soils aren't being used that much, there are plenty of nutrients available in them. There's not a lot of stuff that can grow without the rainfall. And so when you do have those periodic flooding instances, it can cause kind of life to bloom in the deserts. We'll talk a little bit more about deserts later down the slides. Grasslands are going to be very large areas where the primary organism is just grass. And so these are typically characterized by very thick, rich soil. We would call some of these savannas if they are in the tropical zones, and then grasslands as they get further up. This would be an example of what a grassland looks like here. And so you can see that we have seasonal rain. There is a wet and a dry season for this grassland. And so the reason why we don't have a lot of trees in this biome is because these months here, where we don't have a lot of rainfall in the winter time, in the case of this one, the trees can't survive, but the grasses can go dormant and then re-sprout again in the spring as it rains again. Tundra is going to happen at further north latitudes. These are typically very, very poor in nutrients, and there's very little time for things to grow. And so we look at a tundra graph here. Either we do have precipitation, the bulk of it is going to be snow, because our temperature doesn't get up past, what's our highest here, 12 degrees or so. And so you can see that line squished down. This is telling you it's a tundra. Tropical forests have the biggest amount of species diversity, but their soil is not particularly rich because there's so many plants growing. It's going to draw a lot of that moisture out, all those nutrients out. And so it's very, very quick turnover rate. Decomposition happens very fast. The nutrients are used up very quickly. And so there's not a lot of thickness to the soil layers, and there's not a lot of nutrients available in them. And this would be an example of tropical forests. So the tropical ones are going to be designated by having this really, really flat and hot temperature line, right? This is somewhere around the equator, Singapore. It's going to be near the equator, and so the temperature doesn't vary at the equator very much. And they're also characterized by really high rainfall throughout. You can see, again, we've got a rainy season in the wintertime, which would be their summertime in Singapore, I think. Temperate forests, the key to finding a temperate forest are well-defined seasons. And so when we look at the graph, we're going to see a nice bump in the middle. This would fall in our summer, right? June, July, August. If it's in the southern hemisphere, that bump is going to look like this because their summer is happening during our winter, right? January, February, December. And so take a look at one. You can see the bump in the middle. This is showing us that seasonal temperature difference. And so anytime you see seasons, typically thinking temperate in that middle column. And then we know that this has a lot of rainfall throughout. This one's in inches, so not the best graph, but still shows a lot of rainfall throughout. Boreal forests and taigas, these you want to think about Canada and Russia represent a very large landmass of boreal forests and taigas. So they are very similar to temperate forests. The temperature is just going to be dropped a little, and the rainfall is less. And so you can see here, if you look at the scale of this graph, it's different, but the rainfall is about the same as the last one. And then our temperature maxes out just under 70. These climatograms or climate graphs are dictated by the precipitation and temperature in the area. And so one of the most important things for determining these are these ocean water currents. So this red line here are shallow water currents that are warm. And so essentially what this does is it carries heat from the equator, especially in the case of the United States here, it carries heat from the equator and moves it up along the coast. And so because of that, we get very temperate weather all throughout the Northeast, right? We have seasons, there is plenty of precipitation, and so you can see the greenness of this map right here. And so this warm water is going to help control and determine what the biomes are. So it's important for figuring out what kind of biomes we've got. Anywhere this is near land, you can see it's turning the area green, right? We have green here, got green here, we've got green in northern Australia, there's rainforest in here in Southeast Asia, right? This is a very green area of the map as well. Also, we've got green up here. So it's delivering warmth and it's also delivering precipitation. Warm water is going to evaporate and it's going to rain back down. The other thing that's important for determining these biomes are called these Hadley cells. And so Hadley cells are due to differences in heating, unequal heating of the air at the Earth's surface. And so this is going to determine global wind patterns. And so essentially the warmest place on Earth is the equator. It receives the most direct sunlight. And so because it receives the most direct sunlight, let me clear this off right here, erase all link on slide. Because it receives the most direct sunlight, the air there is the warmest. So warm air has lower density, and so it's forced to rise up. And so as this air rises up, it needs to be replaced with air coming across the surface. This air coming across the surface is going to evaporate water, right? We have a lot of oceans that fall between 30 degrees. I'll write that here, 30 degrees and 0 degrees. This would be 30 north. And so as it's moving across the surface, it's picking up water vapor. When it reaches the equator and starts to rise, that air cools as it gets further away from the surface of the Earth. And so we're going to end up seeing storms and rain. And so if you look at our map, I'm going to bounce back here, along the equator, which falls through Ecuador, right here-ish is the equator. All of the land here is very, very green, and because it's tropical and there's a lot of precipitation, we call it tropical wet, and so we got a lot of rainforest forming there. The other thing that this determines is as that air cools, it has to replace that air that was moving before, and so it sinks down at 30 degrees. And so up here in the atmosphere, there's no oceans to evaporate water from. So when it falls back down, it's already lost all that moisture and water vapor, and so it comes back down to Earth very, very dry. Wrong direction. And so if you look at 30 degrees, which is roughly here, we end up with a lot of deserts, right? Huge desert, big desert out here, Gobi Desert right here. And so those deserts are because that dry air is falling down from the upper atmosphere. And it happens again and again up here. So we could follow it, but I'm not going to continue this in the interest of time. Last little piece of biomes that I want to talk about are elevation. And so you can end up having kind of geographic islands of biomes on the side on mountains, right? At certain elevations, the biome is going to change. The temperature is going to change and the amount of precipitation is going to change. And so there are some species that are essentially trapped on those islands at high elevations, even though that mountain might be like in West Virginia. And so that the top of the Appalachian Mountain There's certain types of species that are adapted to that, and as they go down, there's not enough moisture or the air gets too warm and they can't survive. And so elevation is also an important determinant in what the biome is. This little graph right here, while confusing to read, does show you that at latitude 30-ish is where we see a lot of the deserts, right? Here are all the deserts. It also shows you at the equator, right? You're almost always going to be tropical unless you get higher in elevation. Once you get higher in elevation, the temperature cools down, and so that's when you become coniferous and deciduous forests. This graph, not super important, but I thought it was worth showing just to show you that deserts really only occur at 30 degrees. And that is going to be it for this video. Please come to class with questions tomorrow and be prepared to talk about what we saw.